Okay, so this is the last little part that I'm going to make a video of for PowerPoint 1. So the last two I was unable to do in class, and we'll figure out next week where both teachers are. But I'm going to do it anyway because then it's there. All right, so you know Charles Darwin. Everyone's heard of Charles Darwin. He was a philosopher. He was a naturalist. You know, he sailed around on the ship called the Beagle. He was the medical physician, and along the way, he was young. He was 20. You know, he was collecting evidence, and he was figuring out. He was pondering, why is there so much biodiversity? What are all these fossils? You know, what does it show us? How does everything link together? And this is when he came up with his. He started thinking about the theory of natural selection and how organisms change over time into others. Well, not into others, but the diversity of life, okay? He didn't know about genes or DNA or anything like that, and he came up with a theory of natural selection. Now, he wasn't the only person, so he was influenced by Erasmus Darwin, who was his grandfather, and he was also, interested in the natural world, and we don't need to know stuff like this. He was also a doctor and a poet. I'll tell you something there just now. So he also wrote a book called Zoonomia, and he suggested that all life forms had evolved from a common ancestor, and that's what got Darwin thinking, and it influenced Darwin. And he also suggested that the age of the Earth was much older than what they believed, a couple of thousand years. He was, thinking, millions of years. Okay. Now, there's another chap, JeanBaptiste Lamarck. Okay, and you can see that when they lived overlapped a little bit. All right, now he also came up with a theory of how species arose, but he said, or how species arose from other species, but his mechanism was different. Okay, he said that organisms will develop new structures or organs to meet the needs of what's happening in the environment. So it's called the law of use and misuse. So if you use something more, it might become bigger. If you use something less, it might become smaller. So I suppose the tail. If you use the tail less, it's going to disappear. But if you need a tail, then it will develop. Or if you need a longer neck, like a giraffe, to eat the leaves higher up in the tree, then your neck will grow longer. And he said that those traits those new traits were passed on to the next, onto the offspring. Right, but what he thought influenced Darwin as well, but they were looking at it from different sides, if you want to say it that way. So he's also very important, and one of the notes that I've uploaded, or will still upload, it shows you, how they thought differently. So Lamarck proposed the following mechanism of evolution. Darwin came up with a theory of natural selection, and Lamarck came up with this theory where you originally had short-necked ancestors, and they kept stretching their necks to reach higher up in the tree, and that caused their necks to become longer, and those longer necks were passed on to their offspring. All right, but we know, that doesn't happen. You are what you are because of your genes. If you're short, like me, I will be short. I'm not going to grow taller because now I need to reach the top of the blackboard. Well, that's what Lamarck was saying. All right? Okay, so now it's driven by an environmental need. It's driven by an inner need. The organism needs to change to adapt to environmental conditions which are changing. And so Lamarck also, it's also called acquired characteristics, that new traits are acquired because they need it or they no longer need it, so disuse, they lost. All right. So acquired characteristics or use and disuse. All right, so now, the organism, like the giraffe, keeps stretching its neck to reach the higher branches, and then that part will stretch longer and become longer or modified. All right, and that's passed on to the offspring. So I've given you a similar little, well, not given, but it's on Moodle, and I'm going to put on Google Classroom as well, where it compares what the mechanisms that they came up with to explain evolution. So Lamarck said it's the inheritance of acquired traits. So the longer neck is inherited by the offspring. But hang on, mom and dad were short. We know that can't possibly be. If mom and dad are both short, chance of children of being short are almost the same. All right. Capable of transformation from short to tall or whatever, individual changes to meet the needs. The environment is different, there's a drought, and now that giraffe needs to stretch its neck to reach the higher leaves, all right? And therefore they elongated their necks, but they passed that acquired, it was acquired during the lifetime of the giraffe, onto their offspring, resulting in giraffes with longer necks. But we mustn't, we mustn't write Lamarck off. So if you go and read up on something called epigenetics, okay, very interesting. Okay, and if we've got time, we'll talk about that as well. It's not part of the syllabus, but go and read up on epigenetics. So what did Darwin say? So here, Lamarck was saying the individual changed over time because the environment was changing and that new trait was passed on to the offspring. Darwin wasn't saying that. He wasn't saying that one organism changes in another giraffe and another giraffe because they need to reach the higher leaves. He was saying that in a population, just like we have variation amongst all the class people in our class and in grade 12, that there are mutations that allow us to have that mean that we have differences, and they in the natural world those mutations are selected for by the environment. So if those organisms have a mutation that allow them to be better adapted to a changing environment, if a giraffe has a slightly longer neck, just by chance, there's a mutation, then that giraffe will survive while, during a drought, while all the shorter giraffes that really can't reach those leaves higher up in the trees don't survive. So that slightly longer neck giraffe will pass its genes on to its offspring. So it's inherent, it's in the genes, in the DNA. We know about genes and DNA, Darwin didn't. All right? So the ones with slightly longer necks, they were genetically already slightly had longer necks. They were able to survive and reproduce and pass on that longer neck trait to the next generation, and so on and so on and so on, until you had all giraffes having a longer neck. Survival of the fittest, natural selection. They had a mutation that made them better adapted to a changing environment, and the short-necked giraffes didn't make it. They weren't able to cope with drought and not being able to get enough food. So please be very careful when you talk about what Lamarck said and what Darwin said. And that's the kind of question you're going to see. They're going to give you questions where they give you a scenario about whatever, giraffes, whatever, turtles, tortoises of Galapagos, and they're going to say how would Lamarck have explained this and how would Darwin have explained this. All right, so that's what Lamarck said. Okay, that there's a straight line, that simple organisms changed and became other more complex organisms. He wasn't saying, from common ancestor, adaptive radiation, chance mutations giving rise to all the biodiversity that we have today. Okay. And so now there's another chap called Alfred Wallace. And he was also a naturalist, and he studied plants and animals in Indonesia. And him and Darwin, they shared letters, and they even met once. And he also published a paper with Darwin describing evolution. Now, remember I said that Darwin, he was religious, and then he kind of kept away from the church because he was very confused in his head. He didn't even want to go into church anymore because he was scared about what he was thinking and coming up with his theory, and it went against what he believed in. Whereas Alfred Wallace, okay, so Darwin said, if these changes happen, if evolutionary change, natural selection happens to animals and plants, he said it must happen to humans as well. So there must be fossils in that of early human-like organisms that have become extinct, and now humans, Homo sapiens, are the only ones that are still around. So he was prepared to say that, but Alfred Wallace was not. So that's why Darwin's theory of natural selection became the one that we now know it explains the evolutionary process. All right, so let's just see here. So Darwin formulated his theory of natural selection in the 1830s, and he worked on it for 20 years. This was after the Beagle, and he corresponded with Wallace, the previous picture. He was exploring South America and Asia, and he supplied Darwin with birds, specimens that he collected, and he wanted to get help from Darwin to publish his own ideas on evolution, and he sent Darwin his theory. Now, you don't need to know stuff like this, but things like this don't just happen. You can't just open Google or ask Siri, how does this happen? This took years. This is what they spent their lifetime trying to figure out. All right, so, because of this, Darwin was quite shocked that the theory that Alfred Wallace came up was very similar to his own. Okay? Wasn't happy about that. All right, so there's Darwin, very young. He struggled in school. He wanted to become a minister, so he did a degree in theology. He also wanted to become a doctor, but he was quite scared of blood. And he studied natural science, and he sailed on the Beagle. He was only 20-something. He was a naturalist collecting specimens, trying to figure it out. And he was the ship's doctor. And there's the first cousin, his wife, and they had 10 children, but 3 of them died as infants, and 3 were infertile. Okay, so we're going to talk about inbreeding later on. So he started thinking, incest, marrying closely related family members could cause weaknesses in the offspring, which we now know, if the genes are too similar, then you could end up, with children who have genetic problems, okay, because there's too much similarity between those individuals. All right. And he also, he studied breeding, he inbred plants in his garden as well, okay? Okay, so there's his, he was much younger when he sailed on the Beagle. He was an old man already, and there's the trip that he took, and no, you don't need to know about that. But here's South America, and about 400 kilometers away are those 13 or 14 Galapagos Islands. And Mrs. Page, I still got the book that she gave me, and she went the first time, I think, she went there in 2014, and she went another time, okay, and I actually wouldn't mind going there, organising a school trip. So she gave me this book about all the wonder biodiversity and the iguanas and the tortoises, all right, which we're going to talk about now, and the iguanas and so on and so on. Very diverse environment, and also, of course, all the finches. Okay, beautiful environments. Okay, so there are the islands, there they are, there's big ones and small ones, and they're in the Pacific Ocean near the equator. And he was amazed that there was so much wildlife. How did all that wildlife get there? These islands are 400 kilometers away from the mainland, away from South America. So somehow they must have got there, and they had their own nice new niches that they could inhabit and evolve in. So, for example, you get the domed tortoise, the giant tortoises, and I think it's called the saddleback tortoise, and the iguanas, and that they only found there. And I think I'm just trying to remember, there was one tortoise, one male who died last year or something. I need to look that up. Okay, it was a very old man and he died. All right, and different kinds of plants. And I think Mrs. Page could tell you lots of stories about this. Okay, so different islands, different tortoises, different islands, different finches. All right, so the saddlebacked tortoise, the one with the immediate shell, and the dome-shaped one. So these guys reach up high, and these chaps eat lower down. They forage lower down. All right, so the dome-shaped ones, they've got shorter legs and they eat close to the ground, whereas the saddleback ones, they by chance had a mutation or mutations that allowed their necks to be longer, and then they could cope with the different environments and be able to reach food higher up. Okay, and there's finches. We've discussed the finches already, the 13 species of finches that evolved from the mainland finch that is found in South America. Right, so all of them evolved from an ancestral species. There we go. So you have lots of branches here, 13 species evolving from that ancestral species, and they colonized the islands, and they each evolved on their own islands because of the different food, the different niche, adaptive radiation, chance mutations that allow them to be better adapted to the new niche, the new environment that they are in, feeding on different kinds of food. All right. Okay, so in the next PowerPoint, so that's PowerPoint number 2, and that's where we're going to continue with next week. And now, I'm going to upload onto Google Classroom as well my summaries. All right, so the one summary is a single sheet. It's all the, how evolution takes place. So we're going to be talking about that. And the other one, it's actually a double sheet. Okay? Because there's a lot of stuff here. There's lots of little things to remember. So this is what I put together last year, and you can find it on Google Classroom. I will put it there soon today. And you can print it as an A4, and how species are formed, and the mechanisms of evolution. All right, and that's what we're trying to put together. So we've already talked about transitional fossils, and there's quite a few, a movement of water from water onto land we've talked about, divergent evolution from the simplest organisms first over here, increasing biodiversity. So there's quite a few little things that we're going to add in here to finish off the story. And then also here, next week we'll talk about, we talked about gene flow and genetic drift, and we're going to talk about the founder and the bottleneck effect. All right, so these are all just the little ins and outs, the tools in order to explain how evolution takes place. Okay, so that's the end of PowerPoint 1, and we'll chat and we'll see where we actually both start together on Monday. Have a good weekend.